Hi, friends. I wanted to take a moment today to talk a little bit about these graphs that we've been using when we're talking about optimal foraging. So let me go through the example that we did in class and sort of show you one more time sort of what everything represents and how you can very easily graph these things on your own. Here we had an example that Dr. Foster told us about where she was looking at her bird feeder and she had a stopwatch with her and she was looking at the bird that came to her bird feeder and basically just counting how much food that bird was eating. And she did this by counting literally the number of seeds eaten. So you can see that on the y-axis that we have the number of seeds that are being eaten. And she counted these in a specific time interval, which we see on our x-axis here. So if you look up at the top, here's sort of our data table. She watched for 45 seconds, and every 5 seconds, she counted how many seeds were eaten. So in the first 5 seconds, the bird ate 4 seeds. During the next 5 seconds, the bird ate 3 more seeds for a total of 7 seeds. In the next 5 seconds, so at 15 seconds, the bird ate 3 more seeds for a total of 10 seeds. So you can see that for every 5-second interval, Dr. Foster had the number of seeds that were eaten. Now, I want to pause here for a second and just draw your attention to the fact that Dr. Foster measured the food or the foraging intake in terms of like the counting the food items, but she could have very easily done this by looking at kilojoules or joules or calories. So looking at the energy content instead. So sometimes you may come across a problem that's talking about the number of food items consumed, or it might have kilojoules of energy consumed. Either way, we're just saying like how much food is being foraged by this animal over a given period of time. Okay, so now that we've got these numbers, let's plot them. Like I said, you're going to put the energy consumed, number of seeds or kilojoules, on your y-axis, as we see here, and then you're going to plot time on your x-axis. And time is usually in seconds, but it could be in minutes. It could be every 5 seconds, could be every 10 seconds. Whatever the interval is, you just put that on your x-axis here. Leave a little space. We're going to get back to this, but leave a little space in the negative area and plot your times out on your x-axis. So when you do that using these data, it looks something like this, right? We've got our 5-second data point where the bird ate 4 seeds. We've got our 10-second data point where the bird ate 3 more seeds for a total of 7, etc., etc. And then draw yourself a line through those data points. See that line? Draw that line, connecting those dots. This is not one of those best fit lines. This is continuous data, so we're going to connect those dots and draw ourselves a little curve. It's not going to be a straight line. You're going to see that it curves, right? As basically the bird in this example, the animal, will start to, slow down in terms of how much food or how much energy is being consumed, right? This gets back to the idea of diminishing returns, that the longer the bird is in the patch, or the longer the squirrel is in the patch, or the longer the wolf is in the patch, I guess, the less energy there is in that patch to be consumed. And so we will experience these diminishing returns. So you see this same sort of curved shape as we're looking at optimality models. Okay, so I think we've got that part down. Now I know what you're thinking. You're like, what about that straight line that you all are talking about? Right. We will then put in a tangent line to this graph that will allow us to understand the optimal amount of time that the animal should spend foraging in this given environment. And we do that based on the travel time. So if you see up here at the top, the travel time for the bird to get to the next patch is about 10 seconds. So the next food, right, or how long it took the bird to get to this patch in the first place, to get to the next patch, it's in 10 seconds. So that's what this dot is over here, our negative 10 seconds. It took 10 seconds for the bird to get here, to travel, and so that's going to be our starting point. You'll notice no food was eaten during this time because, of course, the bird was traveling. But we're going to start at that point, and then we're going to draw the super straightest line so that it just touches our curve. Just touches our curve, sort of kisses the curve, completely tangent to it. So you see that here, right? We see this nice, perfectly straight line, and it hits our curve right here at this spot. Now, I do want to note, it doesn't have to be 10 seconds. In this example, it's a 10-second travel time. It could be 5 seconds. It could be 50 seconds. It could be 3 minutes. It could be any time. So look and see what the travel time is. That's where you start that line and draw it straight where it touches the curve. And this is the spot where we're going to be able to calculate the optimal time that the bird in this example, or the animal, should spend foraging. And so that's what Dr. Foster has drawn in this beautiful arrow straight down for us, 20 seconds. The animal should forage in this patch in 20 seconds because that's basically when it's no longer efficient, right? It's no longer optimal. You're not getting as much energy out of this patch anymore, because that's when we start to experience this decline, these diminishing returns in how much energy is in that patch. So we would say that this bird should stop foraging after 20 seconds and move on to the next patch. But there's one more thing we can figure out from this graph too, and you probably remember this from our homework assignment. What about that giving up density? The giving up density is really looking at just another measure of basically the same thing, except now instead of talking about how much time the animal should spend, we're looking at how much food should the animal eat before it gives up, or really, how much food is left in the patch when the animal should stop feeding there, when it's going to experience these diminishing returns. So you'll have to figure out how much total energy is in that patch. In this example, I'm going to say there were 20 seeds in the feeder. There were 20 total seeds in the feeder. And so we can use this number, this total energy that's available, and subtract this amount of energy, this number of seeds, 12, because that's when this animal is going to start experiencing those diminishing returns. So to figure out this giving up density, we would take this number 20 and subtract this number 12, giving us this giving up density of 8 seeds. The bird should give up feeding at this feeder when there are 8 seeds left. And this relates to some of the examples that we talked about in class. And I hope that this was a reminder to you, or maybe some review on how we can use these observations to try and figure out a little bit more about this optimal foraging theory. If you have any questions, please don't hesitate to ask. Good luck.